But sitting in a lecture and listening to a professor explain information allows you to retain only 10% of that information. In the medium term, not to talk about the long run. And so, sugar pills, placebos, pure placebos, are more effective at curing disease than our entire educational system is today at disseminating information. That's a shocker. And so not only do we have a problem in what we teach, we have a big problem in how we teach. And this is where thinking about an intentional education matters so much. So now let's take a step back and think about what is it we're trying to do with a systemic, intentional, practical education. In day-to-day life, no matter what profession you're in, we encounter problems. Problems that we have to solve. In order to do that, we first and foremost have to analyze problems. Take the problem and break it down into its component parts. This is what's usually known as critical thinking. You then have to take those component parts and piece them back together. Find a creative solution. What's sometimes known as creative thinking or effective problem solving. Then once you devise that solution, you have to think about what are the unintended consequences of implementing that idea. Sometimes things that are designed to do something wind up doing a whole bunch of other things that actually counteract the intended solution that you designed in the first place. So you have to understand how systems work and interaction effects. And then, because we all live in the world, with society, with other people, you have to then figure out how do you implement and communicate well with other people in order to make these ideas, these solutions, into reality. How do you communicate well or interact well with other people? So these concepts are not particularly controversial. I think anybody would say, I want to hire an employee who is able to do these four things, namely think critically, think creatively, understand effective interactions, understand effective communications. Seems to make sense. But our educational system doesn't focus on these things today. And so when you design a system that is supposed to do these types of things, you have to keep a few things in mind. First, these big capacities, critical thinking, creative thinking, etc., are not homogeneous. They're not a thing. They're in fact composed of many things. Think about critical thinking. One form of critical thinking is evaluating claims. Somebody makes a claim. You can think about how do you evaluate that claim. But evaluating claims is also not a thing. Some claims you can evaluate using logic. Some claims you can evaluate using reasoning. Other claims you can evaluate using statistics. Others you can just think of counterclaims. Right? So each one of those are discrete components of claim evaluation. But then there are other forms of critical thinking. For example, making decision trade-offs. Do I take path A or path B? Well, to figure that out, you may have a completely different set of tools. For example, thinking of a cost-benefit analysis, which doesn't really come in handy for claim evaluation. And so critical thinking is a set of heterogeneous components, as is creative thinking, as is effective communication, as is effective interaction. And we've identified about 100 of these individual components that we refer to as habits of mind or foundational concepts. Habits of mind are easily triggered and then difficult to apply. For example, someone makes a claim, think of a counterclaim. Easy to trigger, hard to apply. Which counterclaim would make sense to apply? Hard to think about. Foundational concepts are the opposite. relatively easy to apply, hard to know when to apply. Hard to know when is the right time to trigger. So for example, a statistical analysis, relatively easy to teach the methodologies behind one form of distribution versus another. Hard to teach the intuitions as to which statistical analysis would go well with what data set. But in both of these situations, context in teaching can be deadly. Because if you teach these ideas in a context, it'll stay there, at best. There's a story that my colleague likes to tell about one of his former colleagues at Harvard who taught an introductory physics course. And this course was taught to the non-physics majors. So these were people who would major in biology or chemistry but needed physics as an introduction. And the professor decided to make the course more relatable. And so throughout the class, he used baseball as an example for physics. Baseball has a lot of physics in it. Trajectories, parabolas, etc. And so the students learned all about physics through baseball analogies. And it was time to give the final exam. And the professor had a problem because throughout the semester, he used every single baseball example he could think of. So when the final exam came, he wrote it using football analogies. The Harvard undergraduates screamed bloody murder. Unfair. You taught us a course about baseball, and now you're asking us about football. We can't do that. Football and baseball are what is referred to as near transfer. Very related to one another. Very different than, let's say, teaching a course on baseball and then talking about car collisions, right? Or maybe astronomy. But the mind just isn't wired that way. So how do you teach it? How do you teach generalizable practical knowledge? Well, the answer is very straightforward. You teach it using spaced deliberate practice in multiple contexts when you foreground the habit or concept as opposed to the subject. So rather than teaching a course about baseball that uses concepts in physics, you teach a course about the concepts of physics contextualized in baseball, and then the same context contextualized in astrophysics, and the same concept contextualized in biology. Now, you may notice that this is not the way universities are currently set up. Universities are currently set up finding people who have subject matter expertise, not that have general application expertise. Portion number 2 is the pedagogical model. How you teach. Explaining, professing to students about these concepts in different contexts won't be retained. We've already discussed how the lecture test-based methodology has a 90% failure rate, meaning 90% of the information that you're supposed to learn in a typical class is forgotten within a few months of the end of the course. We, of course, all know this. If we were to go back today and be given the exact same test, not even different questions, the exact same test that we took as undergraduates, that we got A's in when we were undergrads, we would get F's in today. We didn't learn the material. And so the insight into how to design pedagogy comes from the science of learning and the science of memory. And the science of memory has many different types of principles, but there are really two that are crucial, that are meta ideas, meta maxims that the other components feed into. The first one is thinking it through, and the second is making associations. Let me give you a seminal study, or give you an example of a seminal study that explains or demonstrated how important these things are. A group of researchers asked a set of individuals to come in and look at a list of phrases. It could be cup on table, chair on floor, light near wall, etc. Okay? And they asked the people to read those phrases and memorize as many as possible. They gave them a certain amount of time, then they gave them the test, and saw how many they could memorize. They then brought in a second group of people. And they told them to not only look at each of those phrases, but visualize them. Actually picture the mug that sits on the table, the chair on the floor, the light near the wall, etc. Same amount of time, and then they asked them to list how many phrases they could recall. Turns out the people who pictured the idea, pictured each of the phrases, could recall twice as many of those phrases as the ones that just were told to memorize the phrases by reading. So deep processing, right, helped actually memorize twice as many. But that wasn't the best part of the study. The best part of the study was that there was a third group. The third group were told to look at the same list and were told to visualize each one of the phrases. But they weren't told to memorize them. Just told to visualize, that's it. Under the auspices of doing brain scans and seeing how their brains were activated. And then, after they looked at that list, the time was allotted, was gone, the researchers gave them a pop quiz. They say, okay, now recall as many of the phrases as you can. The shocking result was that the third group recalled exactly as many phrases as the second group did. The one that was told to visualize and memorize. In fact, the instruction to memorize didn't increase memory at all. That's a shocker. Because it turns out that when you deeply process and make associations, you get memory for free, whether you like it or not. And in fact, if you don't deeply process, it doesn't matter how many times people tell you, remember this, the brain won't recall. It's not wired that way. And so when you think about the implications of that for education, it means if students aren't deeply processing what it is that they're learning, they're simply not going to retain it. Hence, they will not learn it. The purpose of education. And so we approach education through a system that we refer to as fully active learning. And fully active learning means that 100% of students must be fully engaged at least 75% of the time. Professors at Minerva aren't allowed to speak for more than 4 minutes at a time, something I have violated many times over. Students aren't just called on to give responses to questions, but when one student is called on, every other student in the class is doing something else to engage with that activity. For example, they may be grading the response that the student that's called on is just giving. They have to always make sure that they are processing the information and creating original applications for it as part of the curriculum. So, this very straightforward concept of creating a scaffolded curriculum, a curriculum that introduces ideas and then reintroduces them at appropriate times in multiple contexts, and the fact that we fully engage the student seems straightforward, right? In fact, why wouldn't every university do it? And in fact, you could do elements of it without changing a thing. So for example, there are activities that you could produce fully active learning in a typical lecture room, right? You could issue puzzles or questions that you have students grapple with, working in teams, right? Thinking about breakouts, thinking about polling, there are all sorts of elements. You could even do semi-active learning techniques. For example, asking a question of students before picking the student that will answer it. Forcing every student to actually process the answer, and then only once processing is done, then calling on a particular student to answer, etc. So there are various techniques in ensuring that. But when you get to a scale where you're trying to teach 100 or more habits or concepts, right, to a large group of students across many professors, many teachers that'll help them in that process, having light issues, right? That process requires data, requires the institution to track how well is a student mastering a particular idea. Right? So if we were to try to teach students claim evaluation, and that was the only thing that we were to do, it's very easy to prepare every professor at an institution that says, well, you know, you have to make sure that students are learning how to evaluate claims, and you have to really make sure that maybe they use these 3 or 4 different techniques. And in your course, make sure that you ask about these things and make sure that students know how to apply them originally. That's straightforward. But when you go to a professor and say, here are the 100 things that I want to make sure that you test students on, that you make sure that they practice in your class in context, it becomes unwieldy. Even when you have a small class, even when you have 15, 16 students in a class, a professor can't possibly assess students on how they have mastered or not mastered any one of 100 different vectors. You actually have to get as many data points on the students from as many different professors and allocate which professor will test on which idea to which student. You simply cannot do that without technology. It's impossible. Similarly, fully active learning, making sure that all students are engaged, especially at scale, is close to impossible without technology. Right? Even things as simple as voting, right, is hard without clickers or some form of technology that polls students and gets their opinions. Professors can instantly see who in a particular class has been talking more than average versus less than average, so they'll know how to draw people into the conversation. All using a technology that enables these very intimate and advanced seminars to occur. There are implications as well for the institutional design.